So I brought down this section box here, and now let's see where this pipe has been drawn. We can rotate the 3D view, and we can see where it's located over here. You can see that the duct that goes up through here actually goes down, which needs to be changed and adjusted later on. These are the issues that we said might appear in the initial modelings. And so naturally, after we're done with this stage of the modeling, and then after that, in whatever phase we're in, we're going to have a session with the contractor. In that same session, the facilities designer needs to be present as well and needs to speak about all of these issues as well as the architects. And so all of the issues will be analyzed and resolved. The beam coordinator actually has a very important role here, and it can be extremely effective and impactful in this stage of the process. So now if you look at the structure here, you can see we have the beam up top here, and so there's no more space to work with. Now we may have the unilet space on the side, which allows us to move this higher up for about a couple of centimeters and get rid of the issue easily. But if not, we may have to remove the suspended ceiling, or we'll have to create an architecture design where we change levels in the suspended ceiling itself. And the sewage pipe here, which is protruding through the ceiling, needs to be changed later on and adjusted using the consultation of the designer. So up to this point, every part that we've done, we've shown an example as well. But for now, I'll go to the 3D view and open up this here, where we can see the middle elevation is set on 2.1, which we can set it to 2.15 instead. Let's see the changes. You can see how there's a collision with the duct. In these instances, the priority is with the fire protection and then the duct. Because of the limitations that are reserved for fire protection, and the checking that it needs to get is completely different from the other ducts and systems, and that's why it has such a high priority. So basically in our modeling, the first priority is the sewage pipes, then drain, and the fire protection after that. That's why we can only build the ducts after fire protection. So here we'll need to reserve our first priority for fire protection and get the placing of that fixed, and as they say, freeze it, and then we can get to the adjustment of the duct. So we shouldn't make any changes to the order of the priority, but we could make changes only and only if we can get the confirmation for the fire protection settings as well. So these are some implementation tips which we need to take an account for on top of the modeling itself. So now I'll be doing the modeling of this pipe here, which you can see the width of is 2.5 all the way through here. Then we have the 1-inch exception, and then from here on out it's 1.5. So I'll use the split tool to split up the pipe through this point. Or I can select the pipe here and use the create similar tool. Then I'll check the inherit elevation option as well. And then using a diameter of 1 inch, I'll start drawing from this point right here, going up according to the line in the plan up to this point right here, where we'll be turning right. Now, fire protection pipes usually have a cane form when you're marking turns. But for now, I'll put the middle elevation on 2.3, and then from this point we start and we go to this point here, and the reason that it's not showing it is because it's above our cut line. So then I'll hit tab to select all of this group together, and then I'll hit section box so we can see this easier. So we zoom in here and you can see the cane-like shape here. So we rotate the view and select this part and connect it to this one. Hit cancel on this, and then we go back to the plan. Then I'll select the sprinkler that we have here, and then using the fire protection pipe tool, I'll put in 2.3 for the middle elevation, and then I'll hit apply. Now the warning says that the pipe given here cannot find the matching point with this segment here. So if I hide the architecture file through the Revit links here momentarily, we can see where the connection goes and how it says it cannot match itself to this segment here. So let's rotate this to the top view and then select the align tool to connect the center point of this with the center of this one, and then using trim we can connect them up, and there we go. So all of the parts where we have the turns need to have the cane-like shape where the water goes through with high pressure and it can exit out the system with high pressure as well. So now I'll go to the plan and open up the view range and put the top offset on 2.35 so that we can see this part completely in the plan here. Then from this point on in the pipe we have 1.5 for the diameter, which we can select through here. Then once again I'll select the welded connection point. Then I'll hit the plus button to make a cross-like figure here, and then right click and select draw pipe. I'll match the height using the inherit elevation option up here, and here we can see the diameter set on 2.5 as well. Then drawing the pipe, we go down here through the plan all the way through these structures, passing these and then finishing for now at this point. Then later on we can divide it. All of the pathways are done in the same exact way. So for the 1 inches that we have over here, I can select this one on the left, excluding the fire protection sprinkler and the connector down here. I'll get a copy of this exact structure and then copy it and move it over here on this straight line next to it. We can also check the constraint box so that they move in the same direction. The diameter is already set on 1 inches, so we can select the trim tool to connect it to the system down here. Now this speeds up our progress vastly. We can check the structure in the 3D view as well. And if you pay close attention to this part, the direction of this pipe goes the other way. So let's go back to the plan to fix it. We just have to move it around a bit. So first I'll select and delete the pipe that we have up here. Then select link and then erase this one as well. Then we move this lower down here. And let's check this out again in the 3D view. I'll select and hide this vent here momentarily because as we said, the priority is with fire protection. So I'll grab the head of the fire protection pipe and rotate it. Let's see where the rotation icon is. So we rotate it around and then let's check it out in the plan. Right click here and select draw pipe. We create a new pipe up to this point here. Then we can select the align tool to lock the center of this with the pipe here. Then right click and select draw pipe and we can continue the rest of the pipe up to the connection point of the sprinkler system. And this is what it turns out like in the 3D view. We'll need to repeat the same process in all of the stages of the modeling of this part and have all of these connection points in mind. And then we'll have to make adjustments for collisions such as these. And I should state another important point here before we go and check the Navisworks, and it's that if you want to check this clash in the Revit itself, in order to demonstrate this, I'll first have to select the pipes that we have here, but I just want to demonstrate. I don't want to get the file heavy, so we'll select these segments and this one as well. Then we can go over to the Collaborate tab, and from the interference check, we can select the Run Interference Check option. Because the category is already selected, the one given here is current selection. And we can also see the categories in pipe fittings and the pipes themselves. So it doesn't recognize ducts. So keep in mind that if you use the fabrication tool in the Revit file, either in the ducts or in the pipes themselves, it doesn't recognize the clashes. Because in this project we've used only ducts, it doesn't recognize them, but the pipes show up here. That's why if you check out the Autodesk site itself, it says you need to analyze the pipe clashes in the Navisworks because the Revit doesn't recognize them. And for example, in structure, it doesn't recognize the collisions of beams, and you'll have to move it to Navisworks. So now we'll finish up the fire protection and then we'll get a quick check at the Navisworks and explain that stuff as well.